Hi guys, welcome back to another video. And yeah, my name is Lakindu and I'm an AWS community builder. And we are going to be talking about how we can build our own PDF generator service using AWS Serverless, where we're going to be talking about utilizing services such as Lambda, SQS, SES, S3, and API Gateway to build a fully end-to-end service where clients can use to generate PDFs and have it notified to them via email when it's ready to download. So ultimately, when we take a look at PDF generation, most developers or most people have the perception that client-side generation is the way to go. In fact, when I first started out as a developer, I too had this idea that PDFs are something that you can generate on the front end, because as developers in the modern day and age, we are mainly exposed to these frameworks like React, Vue, and Angular, where we have these ready-to-go PDF libraries that are already made. So if you were, for example, a React developer, you would have something like React PDF renderer, if I'm not mistaken, where you could actually render the PDF document, design it on the client side itself, and allow the user download it within the browser itself. So when you have those approaches, you would be like, hey, why should I go for something which makes me put in more effort than I need, which makes me implement more code than I need. So ultimately, it comes down to these four factors. So should you actually use client-side generation? So the first one is there is no authenticity when you generate client-side PDFs, because you generate it within the browser. So you are responsible for what you generate. The software vendor or the product that you're using is not responsible for it. So there is no way to be like, hey, this is the real deal of the document. So if you are doing some legal document or something, if you are creating a PDF of a contract or a legal binding or a report or something like that, so there is no way to say that this is the actual data that is there in the backend, because when you're dealing with the front-end data, you can easily open up the inspector tab on the Chrome DevTools and just use the HTML elements and just change the inputs that you need, and you can use that and generate the PDF. So there is no proper way to be like, hey, this is the real deal. So there is no authenticity in it. And then there is no way to trace your steps. So if you are setting up, let's say, a PDF document, you can't ultimately trace the steps that you make because you're doing it all on the front end. So you can't capture IP addresses, you can't capture which device, which location you are accessing it. There is no way to send that information to the back end because you're doing it all on the front end. So at that time, there is no way to capture that information and process it then and there. And then ultimately, both of these approaches, both of these lack of authenticity and traceability, ultimately compromises on security. So you can't keep your content secure, because ultimately these data can be changed, it can be modified, it can be tampered with before it ultimately reaches the end user. So there is no way to say that it is the real deal, mainly with front-end PDF generation. And the final main issue is that these approaches do not scale on large mission critical and high demanding applications, because for example, let's just assume that you were designing your PDF generation to be on the front end, and many people with the low end devices were using this service. So if you were, let's say you were rendering a PDF which was like really heavy computation required, so it had a lot of SVG assets, it had a lot of content to be displayed, a lot of around 100 to 200 odd pages. This way, your browser would ultimately or most definitely block, because it would ultimately block until this until the PDF generation would complete. Your UI would not be interactive at all. So in a way, it does not scale for these large fragment of devices that we have that interact with our applications. So on that note, those are some of the main issues that I have faced, and what I think you will face if you were to implement PDFs on the PDF generation on the client side. So that is where I think our main savior, or as well I like to call it, our hero who will save the day, a backend generation will come into play. So when you talk about backend generation, there are a lot of approaches that you can do it. So the main way is that you can set up some kind of EC2 instance and have a service running there constantly and on, so that you can access it whenever you want it. But you should also always know that generating PDFs are not something that you do on a daily basis. So it's not like you generate a PDF of a legal agreement every single day. It happens periodically. So even if you're generating in agreement of PDF of an invoice, you would do it, let's say, twice a week or thrice a week. sometimes on a very optimistic approach that I'm suggesting here. So in those kind of approaches, provisioning keeping these resources always up and running is not cost efficient, because you will still be paying for if it was an EC2 instance, you would be paying for the hours that it was running. So in a way, this is not an optimized cost efficient approach. And you will always have to worry about, hey, is my EC2 instance up to date? Do I have to update its OS? Are there any security patches that I have to do? You will always have to worry about the infrastructure. And because of that is where we could go into a serverless first approach, where you start thinking about everything in a serverless first way. So you think about, hey, how can I introduce serverless as a priority approach and solve these problems, rather than thinking about it in an unserverless way, where you can think about it in a serverless first approach and then implement the other resources in a way where serverless does not have to be utilized. So if you adopt this serverless first approach, you can actually create on-demand services. So for PDF, you can create it on an on-demand basis, where you can allow your resources to actually scale up when needed. You don't actually have to scale it manually, and you can also allow it to run only when it's needed. So it does not have to always run. It can only run, and you will only be built for the invocation period. So in a way, it's much more cost efficient as well. And when you talk about a proper serverless architecture for PDF generation, this is something that I've recently implemented personally. So I've designed and implemented. So our clients, we would want them to interact with our service. So we would essentially set up a REST API via an API gateway. And then we would most likely have a Lambda function which should invoke this, which should be invoking the services via the API gateway. And that Lambda function would, we could actually set it up to directly generate the PDF on that Lambda itself. Or we can adopt a much more scalable approach where we completely decouple these parts of the systems. So we can have an SQS queue in the middle, which would push the data from the API gateway or the Lambda onto that queue. And then we can have another Lambda which would poll that queue and would be actually responsible for PDF generation. So in that Lambda, we could actually compute the PDF, persist it on S3, and create a signed URL and email it to our client via the SCS. And we can also set up this dead letter queue for our main SQS queue, so that if these messages fail, for some reason, let's say these messages fail, so at that we can push it to the dead letter queue, where we can then find out what the error is, and if it is a programming level error, we can fix it, and if it's another resource missing error, we can add those missing resources and then start a redrive policy where we can push it back to that queue so that it can be processed again. So no data is lost actually here. And you may wonder, hey, why so much complexity on this architecture when you can directly do it into one Lambda? So the main reason is we want our system to scale. So if you do it all in one Lambda function, if you do it on a forward-facing Lambda, all the clients coming to the API gateway would ultimately reach a bottleneck. If your system was extremely demanding, you would most likely hit a performance or a concurrency bottleneck with AWS Lambda, because PDF generations are not simple operations. They take time, because if you are generating on the backend, you would need to spin up a headless browser. Then you would need some kind of API to interact with the headless browser to set the HTML content. And then sometimes if you were like using Google Fonts or something, or if you are loading extensive scripts onto your PDF, you'd have to wait until all of those scripts are loaded within that internal headless browser instance. So that again adds a lot of time. So ultimately you would either hit an API gateway timeout with the Lambda function, which is, according to my knowledge, if I can remember well, it's 30 seconds. So you would hit that limit ultimately, or you would hit a concurrent limit as well. You can potentially hit it if your application is that demanding. So what you can do is you can introduce an SQS queue in the middle, which would completely decouple the management of requests to the management of the PDF, and implement this kind of design pattern where we can call queue-based leveling approach. So with the queue-based leveling, what you can do is you can allow these systems or these individual services to scale independently by introducing an intermediary queue. So with this queue, you can ultimately decide, the Lambda that receives the data to compute the PDF, how frequently should I give it data? Should I wait a few minutes after giving it the data? So with SQS, you can actually set up a delay period where you can be like, hey, after you send this message, wait for a while until this message is, until this time goes up, and then sends a second message. So in that way, you can set up delay seconds as well. And then You can also set up these visibility timeouts to prevent multiple consumers from consuming the message while one consumer is already processing it. So in that kind of manner, you can allow these services to scale independently and allowing your system to be more robust and more resilient. And so in a way that you are making it handle these demanding workloads as well. So that is the kind of architecture that we are going to be implement today, and we are going to be implementing it using an infrastructure as code approach where we are going to be utilizing Pulumi. So recently I've been favoring Pulumi a lot, and I've been liking the service a lot because its capability to allow you to directly code in your favorite programming language, which is TypeScript, Java, .NET, or anything that you prefer. And behind the scenes, Pulumi actually does not use any transpiler to use cloud formation or anything. It ultimately uses the exact programming language that you have written it and uses its own deployment engine and directly deploys that programming language code onto your respective cloud vendor. So in a way that creates a bit more faster deployments as well. So we are going to be using that to develop our API gateway, our dead letter queue, and our main processing queue. And then we are going to be setting up S3 storage bucket with the necessary resource-based policies to prevent these PDF documents from being accessed directly from the public. So we are going to be implementing it in a way that it can only be accessed via a signed URL from S3 itself. And then we are going to be setting up SES so that people can get notified when their PDF is ready with a download link. So on that note, I'll catch you in the next part of this video where we are going to be taking a look at how we can implement this architecture that we just discussed using Pulumi. Alright, so hi guys, welcome back to the second part of this video where we're going to be taking a look at the actual implementation of the architecture that we discussed previously. So if you want a much more detailed approach to this video, I already have another blog post that I've written, which I'll be linking in the description down below, so you can check it out when you're free and have a nice read, where we are going to be talking about the same thing that we are going to be discussing in the video, but in a much more detailed manner. So we are going to be taking a look at implementing this architecture right here, where we have the API gateway, the Lambda, which pushes data to an SQS queue, where we have a Lambda which polls that SQS queue, where we are going to have that Lambda generate an email after storing the PDF in the S3 with the signed URL, and then having another DL queue to store the error messages. So we are going to be basically adopting a design pattern called queue-based leveling approach, where we are going to be splitting these two architecture services and decoupling it so it can scale independently. And all the code that we are going to be implementing today is actually right here on this file, on this Dev2 article that I published on the AWS Community Builders Forum or the group. So we are not going to take time implementing this entire thing, because if we do this, it'll drag this video way more longer than it should be. So it might go on for hours if we start implementing this line by line. So what we'll do is, I already have implemented this code right here. It is available on my GitHub repository, where I'll be linking the URL for the repository down in the description below as well, so you guys can check it out. So we are going to be walking through this code line by line, and we are going to be understanding how it works, and then we are going to be deploying it and then seeing it in action. So the first thing that you can do is you can take a clone of this URL repository. So you can just take the SSH URL. After you copy the clone URL, you can basically open up a terminal and you can navigate to a desired project folder. So I'll be navigating onto my desktop and I'll be creating a new directory. So we'll just call it video PDF. Yeah. And then we'll cd into that and we'll clone the repository. So when we clone this, we are actually gonna be getting a few Lambda layers as well here, because when we talked about implementing the PDF service, it's essentially we take a Chromium engine. So we are going to be running it on this library that we have. It's called Chrome AWS Lambda, where it allows you to essentially spin up a headless Chrome instance directly within a Lambda function with no issues. So that is what we are going to be using here. So we'll just open this up in our preferred IDE. So I mainly prefer Visual Studio Code. So we'll just open that up and then we can start navigating through the code one by one. So yeah, so if you take a look at the code here, so we have this project directory with the Pulumi project, And we initially have these 4 main directories, which is the API and the Lambda functions along with the Lambda layer. So this is essentially the layer zip file. So if we extract this, we are going to be getting it in the required format that AWS Lambda recommends. So it's under the directory. So if you extract this, you'll get it something like you have the Node.js directory here, and then you have the node modules, and then you have the code that is required to run the actual Chromium engine. And then we have the actual API Lambda declaration that we're going to be using here. So we're going to be talking about that. And then we have the S3 bucket declaration, and we have the SQS queue, and we have our main index file. We are going to be importing the resource that we're going to be using. So yeah, let's just get the dependencies up and running. So we'll just cd onto app, and we'll just run npm I, so we can just get the required dependencies. So after we get the dependencies, we can walk through the code. So initially we would need to set up a forward facing Lambda function. As we remember the architecture, first we have the API gateway, and then we have a Lambda that will be invoked by that gateway, which will essentially push items onto a queue. So that is essentially declared in this API directory here. So if you take a look at this declaration here, so we are using the Pulumi crosswalk library, which is a set of best practices that Pulumi has implemented and allowing us to easily implement this infrastructure with the minimum code required. So they essentially abstract all of the behind the scenes requirement, where they provision the stage, the deployment, and the HTTP resources. So everything is managed in under behind the scenes by Pulumi with this entire abstracted class here. So we do this, we can provide the API gateway name, and we are going to be defining the routes, and we are going to be defining a path called PDF, which is a post, and that will essentially have a request body where it uses 2 parameters, which gets the email and the content. So essentially you would if you are implementing this on a production grade application, you would most likely have something like an ID or an event, so you can fetch the data. So if it's an ID, you could pull the data from a DynamoDB table and then compile the PDF with that data from the table itself. That is the most recommended approach here, rather than getting the client-side data onto your PDFs. And then we could construct the SQS parameters. So for the SQS, we would need a message body, and we are going to pass a JSON string, and then we are going to be passing it on to this particular queue, which is also called the PDF processing queue. And we are going to send the message, and then we are going to just return the client the message ID back to the client, saying, hey, this is the message ID for your request that we just put in the queue. Now with Pulumi, you might notice I do not refer to any infrastructure, any environment variables. Everything is defined in the code itself. So this is also known as infrastructure in code, which is a term in Pulumi, where essentially rather than passing environment variables, we let Pulumi resolve these resource names at deployment time. So when it deploys, it essentially knows, hey, this is belonging to this stage, so I'll just use this resource name rather than having to pass it via an environment variable. So after we declare the API gateway, we can look at the queue that we are going to be using. So now that we have the forward facing Lambda and the API gateway, we have integrated that part of it. And then we can start integrating the SQS queue. So for that, we'll just open up our directory SQS. And here we have the SQS queue essentially. We have 2 queues, which is the dead letter queue and the actual processing queue that we are going to be using. So if you take a look at the PDF processing queue in the first place, so here we are using the SQS class here to create an instance of the queue class. And then we are going to be creating it with a visibility timeout of 60 seconds. So what exactly is a visibility timeout in SQS? So in SQS, when you take a look at visibility timeout, it's essentially when a consumer receives a message, it has a specific visibility timeout for that message. So that means when the consumer receives the message, no other consumers will be able to process that message until the visibility timeout is finished. So for example, if I have this visibility timeout 60 seconds and the Lambda polls and gets the message, the Lambda function has 60 seconds to process the message and to delete it from the queue. If not, it will be made available for another consumer to process. So if you do not even clear the message, there are chances where your message might get double processed or triple or an infinite number. And then you have the message retention seconds. So that is essentially going to be like, hey, after how long should I actually clear the messages in this queue? So here I have set it to 24 hours. So we are going to assume that after 24 hours, all the messages in this PDF processing queue will get cleared. And this is not going to be a first in, first out queue. And we are also setting a delay second here. So what exactly is the delay second? So it says the time in seconds that delivery of all messages in the queue will be delayed. So this essentially helps that other Lambda function which keeps polling this queue to scale. So it does not need to rapidly get the messages just here. Take it. It does not go in like first you go and then you go and then you go. So it does not go in like a much more constant pace. It rather takes a pause. It waits for 10 seconds and then sends the next message in. Then waits another 10 seconds and then sends the next message. So this allows that other polling Lambda function to scale up without actually being much more resource intensive as well. And we have a read drive policy. So the read drive policy is essentially where we configure the dead letter parameters. So essentially we are saying that use this dead letter queue with the providing the yarn of it. Again, this is resolve that deployment time. And we are going to be like, hey, SQS, if this Lambda function fails to, or the consumer fails to process this message 3 times, you can send it to the dead letter queue. And in the dead letter queue, have a retention of 14 days. So after 14 days only, you can clear the messages. So essentially those are the declarations of the queues. And then we have another event. So what the queue event is, essentially, we're going to be like, hey, PDF processing queue, here's the Lambda that's going to be using you to poll for data. So that is essentially what the events are. So here we have defined a Lambda function, which we keep polling this queue for data. So if you go into Lambda, we can see the Lambda function there. But first, let's go in line by line here. So initially we are declaring the Lambda layer. So what exactly is a Lambda layer? So Lambda layers are a nice way of packaging up your code. So for example, if you were having like, let's say a common logging function or something like that, that would be used in every Lambda function. If you were to include this one by one, you'd have to replicate the code. But then that is much more tedious. So what you can do is you can use a Lambda layer and package that up as a separate section or a separate library, for instance, in that matter, and then include that Lambda layer onto these Lambda functions that use that actual logging function. So that's the same thing for our PDF layer as well. But here what we have done is, because this library is about 50 megabytes, it will ultimately exceed the size of an individual Lambda function size. So when you include the Lambda layer, you can solve these storage issues as well. So that is why we are storing this PDF library within a Lambda layer. So in Pulumi, we create the Lambda layer and we are going to zip this. We are going to create a file archive from this zip file. So essentially that's going to be uploaded onto Lambda as a Lambda layer. And then we have this PDF processing Lambda, which is going to be polling the PDF processing queue for data. And here we are going to be getting the queue data here. So these are the queue data, and then we are going to generate a PDF. So this generate PDF function is declared here, where essentially it takes in the content that was passed in from the client to generate this PDF. So here we can see that we are requiring the Lambda, or we are requiring the library that we are going to be using in the layer. So this library essentially comes from this parameter here. When you say layers, we are including this layer. So we are defined the layer here, and we are going to be binding that layer onto this Lambda function. So at deployment time, Pulumi will be like, hey, this Lambda function will be using this Lambda layer as well. So with that, we can access this library as well, because that will be stored in the temporary storage of the Lambda function during its after deploying as well. So here we will be creating an instance of Chromium using Puppeteer. So Puppeteer is a nice library, which it's basically an API of sort where it allows you to control these Chromium tools, allows you to essentially control a headless browser with these Chromium protocols. So essentially you can do stuff like you can open new pages, you can navigate to these certain URLs, you can set these contents and ultimately generate PDFs as well. So here what we are going to do is we are going to be creating a headless instance of Chromium using Puppeteer. And then we are going to be launching a new page. So that is essentially a blank screen. And then we are going to use this HTML template, but you can also design these custom templates with custom fonts where you interact with Google Styles, Google Fonts, and you can have style sheets. You can even set up a nice HTML template on this same project, and you can import that using, Node file reader, file system. And you can set the content, and then you can generate the PDF and return it back to the Lambda as a buffer basically, because this returns basically a buffer stream where you can use it to store it directly onto S3 with the storage buffer. And then finally, always we have to ensure that we clean up our resources. If not, this might cause memory consumption to be very high. So we close the browser instance if it is created. And then after we generate the PDF, we are going to use a name. So for this, I've just chosen a PDF message ID as a name, but you can be much more creative and use an NOID or even a custom name that the client may provide. And you can persist it on S3. So here I have done the central EU central one region is because I've chosen to store this on the global infrastructure, which is as S3 is designed in that way. And then we are going to be storing it in S3 with a content type of PDF, and then we're going to be storing the buffer, and we are going to be storing it in a directory. So our file would be stored in something like, so we have the bucket, and inside the bucket we would have a directory called PDF, and inside that we would have the PDF file. So for all those who are asking about this autocomplete, that is actually GitHub Copilot that I'm using. It's quite nice as well, so you can try it out as well. So this is essentially the file convention, that how the files will be stored. Inside the main bucket we'll have a directory called PDF, and inside that we'll have a PDF file. So after we store the information, we can essentially create a signed URL using the get object operation, where we are going to be using the same key and with that bucket. And then we are going to be creating an expiration date for the signed URL for 7 days. This is because 60 minutes into seconds into hours, yeah, and then into 7 days. And after that, we are going to be creating an instance of SCS on US East 1, because that is where my identities are. But based on your identities, you can create the SDK instance on the required region that you prefer. And then we are essentially going to be sending a plain text message. You don't have to do anything fancy here, but if you want, you could send like a templated email as well. But I'm choosing to send a plain text message saying that, hey, your PDF is ready to download. So you can click on this and it'll download it. And then most importantly, we need to do our cleanup processes and delete the message from the queue. So for that, we are going to be calling the SQS delete message API method, and then we are going to pass in from which queue when which recipient handles. So essentially which message to delete. And that's essentially it for this Lambda function. And yeah, we are going to be giving it some policies. So with these policies, with Pulumi, you don't have to essentially define these managed policies. You can directly use the enum with the managed policy enum. I'm giving it SCS access, S3, SQS, and Lambda basic execution role and CloudWatch. So I have not followed this principle of least privilege, but when you implement it, I recommend you give only the privileges that it actually needs. And also I've given around 3 gigs of memory because, as we mentioned, PDF generation is quite a more resource intensive operation. And because of that, we need to ensure that it has a lot of memory so that it doesn't run out of memory. And I've purposely chosen the Node.js 14 runtime because this Chrome AWS Lambda has certain issues with the Node.js 16 version. So today I was experimenting with it. And this library does not work when it's being executed on a Node version 16 environment. So I recommend using 14 or lower. And after we set this Lambda function up, we can essentially provision the bucket that we need. So essentially we have discussed this bucket parameter here. So we need to define the bucket. So the bucket is essentially a normal SQS3 bucket where we have this bucket name, and we are going to give access control list as private, and we are going to give 2 main IAM policy statements, which are basically resource based policies, where we are going to be like, hey, only Lambda functions would be able to insert items to this bucket. So no one else can write buckets. So not even an EC2 instance can insert an object onto this bucket. And then we are also going to be allowing only Lambda functions to get the object for the signed URL. So directly from the public, we are preventing this access. And again, we are deploying it on the global infrastructure. And after that, we can essentially deploy this by importing the required architecture that we need. And then we can update this one parameter here that I mentioned, which is essentially going to be used as a sender email for SCS. So you can replace that with your verified identities. So I'm going to include my verified identity, which is lakindo.development@gmail.com. So that is one of my verified identities here. And that will be essentially used in this lambda function here. So essentially it will require the pulumi config and get this here, and based on this it will use this to send the email as specified here. And then so here you can see that the region that I'm running it on is US East 1. So to deploy this architecture, what we are going to do is we are going to cd into that directory, cd app, yeah, sorry about that, and then we are going to just run pulumi up, and when we run this command it will essentially preview the data. So here we can create a new stack because we don't actually have one. So here what I'm going to do is it says to create a stack in an organization, so we'll just call this pulumi PDF gen. So essentially ensure that you have your Pulumi CLI and AWS profile configured, and you can log into your Pulumi profile account to do this. So as you can see, we run into a small error, so we can see what's the issue here. So it says Pulumi missing required variable PDF generator send email. So I think I've actually added it, PDF generator send the email. Yeah, I know what's the issue here. So we can delete this stack here. So let's debug this error. So here we can Pulumi up and see what's the issue again here. So I've actually added this. So we'll just give this exact name that I've added here. So yeah, now let's see what's the error here. Okay, so still it's throwing an error here. So here, please set a value using, okay, so yeah, let's just set the value using the command that they are specifying. So set PDF generator. Okay, I think I found out the error, guys. So essentially we have to define a stack in Pulumi. So essentially a stack is basically it's like a basic stage environment here. So we have to essentially remove this stack here. So because I am actually on this stack called dev stack here, so I have to create a stack called dev here. So that's the issue here, guys. So we'll just provision a stack called dev here. So we put dev here, that should essentially solve our problem here, because then it will be reading from this configuration file called dev. So pulumi.dev is basically, hey, in the main project use the dev stack. So what I initially did was I typed it wrong and I gave a different stack name here. That's the issue here. So now you can see it's basically previewing all the resources that it needs to create. So now we'll just give it a yes, and now it will start provisioning the resources. Alright guys, so after you finished deploying this, I actually had to deploy it twice because of a small issue with Pulumi with the API gateway and how they manage it. So for that, that issue was solved by adding this binary media types args. With the REST API. So I performed this update twice, and now I have the system up and running. So now we can actually copy this invocation URL for the API. And actually before we do that, let's just take a look at the actual infrastructure that we provisioned. So we'll just head over to my AWS console, and yeah, let's just head over to S3 first. SQS and of course Lambda. So if you go to S3, we can see our actual PDF bucket here, and then we have the our two SQS queues provisioned here, and then we have two Lambda functions. So as you can see, we have used 50 megabytes of the storage, which is actually the Lambda layer which is taking up most of it. So this is the Lambda layer that we have deployed, and so yeah. So now we can open up Postman actually. So we can open up Postman here. So I've actually tested this in the morning today. So yeah, we can set up another post request, and the endpoint is PDF, and let's just give a nice JSON body here. So here I remember we are passing in an email, so I'll just pass in let's say another verified identity of mine would be yeah, we'll just pass in another email of mine, and then we need to pass in a nice content. So here we can just pass in, this is a test body for the email, and so yeah, so we can just send the post request, and API gateway will process it. And so yeah, that's the message ID that we have gotten saying here the message has been successfully processed. So if you go to the code level, so now we are actually right here. So here it returned this. And then if you go to CloudWatch and let's head over to the Lambda, which will be creating the Lambda, the PDF. So we'll just head over to that. And let's open that up in CloudWatch. So now if we actually open up our cloud log here, our CloudWatch log stream log, so you can see that it has been deleted. So that means it has been processed perfectly. And if we go to our SQS, so we can see that there are no messages in flight and no messages. That means it has been processed and not stored anymore. And if you go to S3 bucket here, we can see that there's a directory here and there's a PDF generated. So we'll just open it through S3 and see how it looks. So just open it through S3 itself and then check the email. So yeah, this is the HTML that we are created. So as you can see, it's a nice PDF that has been generated here. So we can download this PDF and it will download the PDF. And so this will be expired within 7 days. And taking a look at the actual email. So yeah, usually I actually get this on the junk because of the way the email body has been structured. So I put in this email. So let's just head on to most likely the Gmail. So it'll be on that junk, I think. So now that has been gone to the inbox, I think. So yeah. So if we click on this, so you can see your PDF is ready to download. So yeah, so if we click on that, that will ultimately open that up. So yeah, that is the actual download email for our PDF. So yeah, it's as simple as that, guys. So with the AWS serverless and with the way that we design this scalable architecture, so going back to our drawing board here. So if you take a look at the initial architecture that we were proposing here, so this architecture that we have implemented here is not only resilient, but it is also quite scalable and high performing, because we have completely decoupled our API gateway with the actual PDF process, PDF compilation. So it allows these processors to scale independently of each other, where we have implemented this event-based, queue-based leveling approach. And that allows us to ultimately create such scalable and highly available systems via serverless computing, while being able to create, implement, and use cost-efficient architectures. So on that note, that is all that we have that we were going to discuss in the video. So I hope that this video has been insightful for you all, and I hope that you all were able to get something out of this. And drop your comments down below and let me know what you think of it, and see you until next time.